scholars. Miss Janice and Trixie here, and we are here to review about topographic maps. So let's jump into it. All right. Today is Wednesday, May 20th. And yesterday we reviewed how the convergent, divergent, and transform movements of tectonic plates at boundaries create land features such as volcanoes, rifts, mountains, and lots of earthquakes. And today we are going to look back at how to interpret topographic maps. Per usual, let's start off with our objectives. Scientists, today you will be able to interpret topographic maps to identify land features, and you'll also be able to calculate the difference in elevation on topographic maps using the contour interval. Let's review on what topographic maps are. Topographic maps are maps that show us the shape and elevation of the land surface as seen from above. And they do this using contour lines. They allow us to map three-dimensional figures two-dimensionally. So think mountains, hills, plains, plateaus. Remember our Plato mountains from class? Well, we created our own topo maps, and we traced each new layer at each elevation. And the highest point of our mountains being our smallest circle. Let's take about 5 seconds to point out a couple things you notice or remember about these topo maps on the right here. Jerry, what did you notice? All right, some line. Wait, what do we call those lines? What do we call them? Do we remember? Yes, we call these lines contour lines. Okay, so some contour lines are bold or they're darker and thicker than others. Perfect observation, Jerry. Haley, what did you notice? Okay. Some lines are closer together, like we see on this steeper slope, and some lines are farther apart, like we see on this more gentle slope. Great observation, guys. Let's take a closer look at the different components of topographic maps that we just observed. Let's start with the contour. So the contour is the outline or shape of a landform. So think its base or the outer line here. So the first line that we traced around our Plato mountains was the contour. And the contour is very important when drawing contour maps as it represents the shape of the entire land feature, like this example here. So we can see it has this long left side that has a gentle slope, and it's represented here on the map, this long left side, and my lines are farther apart, so I know that this is a gentle slope. So, and it also is showing that it's flat on top. I kind of have a flat top here. So when you have these questions asking you to determine the landform, really pay attention to that contour, the base shape. Is it long on one side? Is it gradual? Where is it the steepest? Does it have 2 points? Take the time to analyze these and ask yourself these questions, y'all. So we call the other lines in our topographic maps the contour lines. Now, a contour line is a line on a topographic map joining equal elevation. By that, I mean I can pick a line and follow it all the way around the map, and the elevation of that line is the same all the way around. So let's look at this one. I can find this 1250 here, right? And I can follow it all the way around the map. And all the way around, it's still 1250, all the way around. Now, our contour lines do not touch and they will never cross. And we notice, like Haley said earlier, we notice that some lines, they're closer together and some are farther apart. But when the contour lines are closer, the land feature is steeper, like we see here. And when the contour lines are farther apart, like over here, the land feature is less steep or more gentle. And Jerry also noticed earlier that some lines are darker or bold. We can see some here. Well, we call these lines the index lines. So the index lines will always be bold And they're awesome because they will always have an elevation labeled on them. Like this index line is bold and it's at 11,000, doesn't have the unit, so we can say 11,000 feet. So now that we've reviewed the components of topo maps, our contour lines, our index lines, let's look at how different land features look on topographic maps. So mountains and hills can seem similar on a contour map. So that's why paying attention to the elevation listed by the index lines is really important. So mountains will also have sides that vary in steepness. So some sides are very steep, like over here, this side of this guy is pretty steep, while some are less steep. So see, the lines are farther apart. The highest point is the smallest circle. And mountains will sometimes have more than one point, like we see here. There's 2 points and 2 smallest circles. And with hills, our lines are farther apart, showing that kind of gradual incline. It's not steep. It'd be easier to walk up. But it's still got the circle, smallest circle as the highest point. I'm not really sure if I've got a mountain or a hill over here, but I really like that it really visually represents how the contour lines represent the elevation of this feature. Okay, a depression is basically a big old land pothole. So its elevation is going to be lower than that around it. And this decrease in elevation is represented by these little hasher marks. So in this top right-hand corner, we have 2 circles, but we know that this one is the depression because of these little hasher marks. So we look at these marks, but we can also look at the elevation. So I see 260 here. My next line is 250, and then I have 240. So I can see that decrease in elevation. So a cliff has a very steep drop, and that is represented also by these little hasher marks, which makes sense now that we know those represent a decrease in elevation. But it could also be represented by the contour lines kind of connecting to depict a pretty straight down drop from the same elevation. So here it looks like this is a pretty straight down cliff from about 500 feet. A valley will have a V or a U shape that will point to higher elevation. A river will also have a V or a U shape. But Miss Shanice, I know y'all. I got y'all. The cartographers got us. A river will be clearly marked with a line like we can see here. Now, when a question asks you which way a river is flowing based off of a topo map, don't get tricked. It's super easy to get visually confused here. Like it looks like this river is flowing this way. It looks like the river is flowing this way. But that is not the case. We've got to pay attention to the elevation on our contour lines, guys. Can water flow uphill? No, it always flows from a higher elevation to a lower elevation. So check this out. This looks like it's flowing this way, right? But if we look at our elevation, I have 1,000 here, then I have 1,020 and 1,040. Water's not going to flow uphill. It's actually going to be flowing this way. And the same here, I have 500 and 550 here. So even though it looks like it's flowing this way, I know based on this elevation that this water is actually going to be flowing this way. So don't get tricked, guys. All right, now here comes the good part, calculating our contour interval. Now, the contour interval is the difference in elevation between contour lines. So the difference in elevation between these 2 contour lines is the same as the difference in elevation between these 2 contour lines. Doesn't matter if they're far apart or close together. The same amount of elevation is going to be between each contour line. Once we know our contour interval, we can use it to determine the elevation between 2 points. It's cool, right? So here's how we do it with some easy steps. We've already worked through these steps the last time we talked about topographic maps, so this should look familiar to you guys. But first, we find 2 index lines. And like Jerry told us earlier, our index lines are our bolded or dark lines with the elevation listed. Once we've found two index lines, we subtract their elevations. Once we've done that, we ask ourselves, are the lines next to each other? If they are, what we just calculated is our contour interval. Yes. If they're not, then we need to count the number of contour lines between them. When you do that, you don't count the first one, do count the last one. Then you will divide the difference that you've got from step B by that number you just found. I hope that doesn't seem confusing to you guys, but just in case, we're going to do our first worked example using this topographic map here. The question is asking us, what is the contour interval of this map? All right, guys, let's do it. Our first step is find two index lines. So I'm looking for those bold lines. Found my first one is at 1440. And my next one I see here is 1840. When subtract, so there's my two index lines. So I have one that's 1440 and one that's 1840. Perfect. First step is done. Easy peasy. Second step, subtract the elevations. Always subtract the big number or the small number from the big number. So 1840 minus 1440. And that's going to get us 400. Feel free to use your calculator because I definitely did. All right, so now we have our difference from this bottom point to the top is 400. We're going to say feet. Now we'll move on to the next step. Are the lines next to each other? Nope. So let's go down to this step. We count the number of contour lines between our two index lines. We don't count the first one, do count the last one. So we're going to skip that first one and count 1, 2, 3, 4, and 5. I'm going to go ahead and write that number down so that I don't forget it. We have 5 contour lines between the index lines. Okay. Then we will divide the difference from step B, so 400. We will divide our 400 by the number we just found, which was our 5 contour lines. And 400 divided by 5 gets us 80 feet. So that's it, guys. We have found our contour interval. We found our two index lines. We subtracted them to get 400. We counted how many lines were in between those two index lines. We got 5. So we divided our difference of 400 by how many contour lines of 5 to get us 80 feet. So with each line is increasing by 80 feet. And we can make sure we're correct and check ourselves. It is 80 feet. Yes, great job, guys. Let's move on to our next worked example. Okay, now we just did an example finding our contour interval. So with this one, let's determine the difference in elevation between 2 points using the contour interval. So using our Ruby strategies, let's work through this question. Whoops. Okay, a student stands at the point marked X on the topographic map below. I need to remember where they're standing, so I'm underlining X. I'm also underlining topographic map. And when they're asking me about a topographic map, I know that they're probably going to ask me about a shape and or the elevation of a land feature. What height in meters must the student climb? Oh, what height? What's another word for height, guys? Yes, elevation. So there it is. We are looking for the elevation of a land feature or the elevation in a land feature. So what height or elevation in meters must the student climb in order to reach the top of the hill? So I have my starting point of X, my end point or my goal point. I need to reach the top of the hill. So just so I have it visually on my map, I need my starting point is X, and I need to get all the way to the top of the hill, which is represented by this triangle, and its elevation is 303 feet. So this question is asking me the distance between my starting point of X and my endpoint of 303. So I need to find the difference between 303 feet and the elevation of x. Now, to find this distance, we need to know the difference in elevation between each contour line, or our contour interval. Now, we know how to find our contour interval using our steps like we did in our last example, but if we look at our map, our contour interval is given to us. It's 10 meters. So each contour line should be 10 meters more than the last. Since we have some solid information that's going to help us answer our question, we might as well write it down. Our contour interval, we know, is what? 10 meters. Great job. 10 meters. What's our goal point or our end point? How high are we trying to climb? Yes, 303 meters is the top of the hill. So we need to know point X. We need to know how high of an elevation point X is at. Now, in order to find the difference that we'll need to climb, we'll use our contour interval to calculate from 0 meters all the way up to point X. And our contour interval is 10 meters, so we'll just go up by 10 each line that we count. So we don't count the first one, and we go up 10, 20, 30, 40, and 50. Or we can count the lines 1, 2, 3, 4, 5, and multiply the number of lines by our contour interval. 5 times 10 gets us 50. So now we know the elevation of point X. It is 50 feet. Now all we need to do is find the difference from our goal point and our starting point. So we'll subtract our two elevations, our goal point of 300 meters, minus our starting elevation of 50 meters, which we found out using our contour interval of 10. So 303 minus 50 gets us 253 meters. So in order for the student that's standing at point X to reach the top, she would have to climb 253 meters. Great job on that one, guys. All right, when I say go, you guys will jump to your independent practice, and you will do so by clicking next under this video. You will then answer all the questions on the next page using your Ruby strategies. Click submit when you are finished. You also have a great day. Please feel free to email me or Miss E if you guys have any questions, and please refer back to this video to look at those worked examples. Look at the slides if you need to help you on your classwork. Thank you guys so much. I will see y'all soon. Bye.